Hello, students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, Torrance, California. I'm here again with the design example for pizza cost calculation and order processing, video 2 of 5. In video 1, please watch video 1 before you watch video 2. They have to be watched in a sequence. In this part, we do IOA variable mapping, in which we do input variable mapping, computational variable mapping, and output variable mapping. Meaning of those is that input variables will be inputted by the user with proper prompt. Output variables are outputted on the screen for user to see. Computational variables are intermediate variable which may use the input variable, mathematical expressions, Boolean expressions, and expressions to facilitate computation of output variables. Mapping ahead of time makes sure that correct data type and names have been chosen for all the variables. For name choosing, C++ naming rules have to be obeyed. Correct data type choosing makes sure that by choosing wrong data type, errors are not creeping into our computations. Okay, so just brief review of part 1. Part 1 we said person is going to go to pizza store. They will order pizza of any particular size, small, medium, large, and extra large. There's a base cost associated. Then they can choose type of flour in the pizza crust, and if they choose anything other than regular flour, there's an extra cost involved. And if they choose extra cheese, jalapeno, goat cheese, there's extra cost involved. And if they choose toppings, any of these, extra cost is involved. We will do these computations, make use of these in video 3 and video 4. But right now, we're just going to map the variables. Okay, so how's variable mapping done? First, we take the simple names for variable, which are not C++ names, and we kind of understand their nature, and then we decide data type and names for them. So in this program, we're going to be asking customer's first name. Any friendly pizza store will ask customer's first name and print out a receipt if they want to be printed out, or greetings with their first name. So we'll have them input their name, first name only though. Then they'll select a pizza size. We'll tell them what choices they can have. Then they'll select flour type of which pizza crust is made, and we'll tell them what options they have. This will be done, of course, in analysis and algorithm. Then we will ask them what cheese options they have, and then the topping options. You can use either int type for all four, character type, but we have, for customer, there's no other good data type other than string. So we're going to be using string for that. But for others, you can choose character, string, or integer. But we have chosen a good mix of the two. We have chosen character for pizza size and character for cheese options, but integer for floor type and integer type for toppings. You never want to use floating point type for options, okay? Because that's not a good thing. Okay, so this was the list, and now we are choosing the C++ names. So for customer name, variable name will be name, and obviously it has to be a string type, and we're only going to ask their first name, okay? Code is the pizza size, and that's a good data type for that is character, because we'll tell them they can enter S for small, M for medium, L for large, X for extra large, and those are the choices you saw in table 1, suggested choices. So that's why we are choosing those. And then for flower type, again, this time we'll use int, and 0, 1, 2, 3 are possible values, which you saw in table number 2 here, 1, 2, 3, 0, 1, 2, 3. And then for cheese option, the variable name is cheese code, is character type, R for regular, E for extra cheese, J for jalapeno cheese, G for goat cheese. And finally, we have toppings, 0 no topping, and I can find out what 1, 2, 3, and 5 all toppings, and then we can look at what those are. And for that also, int data type is a good data type. And we can look at the table. 1 is mushroom, 2 is shrimp, 3 is olives, 4 is pepper, and 5 is all these mushroom, shrimp, olive, peppers, okay? All right. Now, computations have to be done for the base cost, and these are not in any particular order. These are not the order in which you will be using them. But we'll need a Boolean flag to know whether they entered a valid size code or not. Because if they didn't enter S, M, L, or X, we cannot process their order. So a Boolean flag will be set to know that they entered one of these. Boolean flag will be true if they entered one of these. It will be false if they didn't enter one of those. And similarly, we need a flag for valid flower code, which means we cannot process their order unless they've entered 0, 1, 2, and 3. And a Boolean flag will be true if they entered that. Boolean flag will be false if they didn't enter any of these. And same applied for the cheese code. If they entered R, E, J, or G, then flag for cheese code will be true, otherwise it will be false. And same thing with the topping code. If they enter 0, 1, 2, 3, 4, or 5, then we have valid flag, true flag for the topping code, because we can process their order. Otherwise, the flag will be false. Once we have computed the cost, we'll have the total cost before rounding to dollars and cents. And then we'll find total pennies before rounding then rounded number of pennies, and also after computing base cost, we'll need to compute these costs: flour increment, cheese increment, topping increment. If they use regular flour, regular cheese, no topping, those will be 0. Otherwise, those are computed with the formula given in table 1. In next video, we'll see more details. So there are 11 computational variables in this case, and we have chosen the word flag added to the case where we want to find out whether they entered correct value. Base cost is double type. These are all Boolean, and this is the first time you're using this data type, so understand that very clearly how that works. And of course, how this is set up, we are going to show that in the third video in analysis. But for the time being, understand that this will be set in a way that this variable will be set to true if they entered code for pizza size as S, M, L, or X. So we get 4 flags that way: one for the size, one for the flour, one for the cheese type on the pizza, and one for the toppings on the pizza. And what value will be set to true is given for each case. You can read it. Of course, total cost will be double type. I have mentioned this many times, that money is double type if it's in dollar cents. And this is the cost of pizza that customer will pay. And this will be the raw dollars, dot cents. And then, of course, to round it off to whole dollars and cents, we find total pennies by multiplying total cost by 100. And then rounded pennies will cast this number to int type after adding 0.5. And then we'll get dollars and cents from there. And of course, as I mentioned, if they chose extras, then there will be increase in cost due to flour, double type, cheese increase, double type, topic increase, double type. Okay, so summary here is that all the costs except rounded pennies are in double. And all the flags are Boolean type, data type. So now you can understand that how we choose the data type, and in the algorithm we'll show you how they're set. Actually, in the analysis we'll show you how those are set. Algorithm, they will be explained in more detail. Output variable are just 2 in this case: cost of order in whole dollars, cost of order in whole cents. Of course, we'll say hello to them in a way. In that case, their name input variable is being also used as the output variable. So that happens sometime, that one of the input variable or more could also be the direct output variable without any changes. If cost is whole dollars, that will be int type, and the cents part of the whole cost, not the everything in cents, leftover cost in cents, and that's also int type. So now you might be surprised. In this case, there are 3 groups of variable: input, computational, and output. You might be surprised by the so many computational variable, because more computations your computer does in a program, more computational variables will be there. And as you can see, in designing pizza software, as we are adding base cost, cost due to flour, cost due to cheese, cost due to toppings, There are quite a few computations to be done, and if we are seeing whether valid input has been done or not, then we'll have the Boolean flags set up for that. Okay, so this could vary differently in different software. Some might have large number of inputs, but not too many computations. Maybe have several output. So this all depends on the type of software you are developing. Okay, so in each case, you'll have to map them out differently. Okay, so purpose of this video was only to explain names of variables, input, computational, and output. They're C++ names, as we have done in 3 different tables. And more description about them. Okay, and we will use all these in analysis and later in algorithm, and then of course in source code. All right, so that's it for video 2 of design example 3, and we have 3 more to go. This was variable mapping. Thank you. See you in the next video.